Hello and welcome back everyone. It's puzzle time with Sudoku Sleuth, and today we are taking a look at little zippers. Is it little zippers? I think it's actually called happy little zippers. And it's a happy little zipper because it's a much more approachable puzzle for what I think is probably a monster of a puzzle that's coming this weekend. Now, it's all about little zippers, which is a brand new Sudoku variant rule that you may have seen featured on a few other channels. And you can see, obviously, we're looking at a tailor's table here. We can see that the tailor has actually attached a zipper to a shirt, a blouse. I'm going to go with a shirt, t-shirt maybe, with those little zippers. Well, I think I'm probably confusing you by just not talking about the actual puzzle. Let's bring it up now. So we've got Happy Little Zippers by GDC. And first rule is fairly straightforward. We know what this is. This is normal Sudoku rules. So that means the digits 1 to 6 in this case, in every row, in every column, and in every 3 by 2 box, as you can see with these dark outlines. Now, the new rule here is the zipper line rule. And this is good practice for the 9 by 9 puzzle, which I'll be honest with you, I really struggled. And I'm saving having it posted for the weekend, where I think just in case you struggled like I did, you'll have plenty of time to be able to actually work your way through it. So what does a zipper line mean? It means digits an equal distance from the center on the lavender/zipper line must sum to the digits in the middle of that line. So let me make that a bit clearer. So for example, if we take this purple line here, these two, which are equidistant from the center, which is here, will sum up to a value. So these two purples, even having the fact that they're both purple, they absolutely can be different and may well be different. These two cells, when you add them together, will add up to this value in red. It's also true that these two values, let's go with green, will add up to red. And then lastly, these two values, let's go with yellow, you sum them up, they'll add up to red. Same can be said is true for this line, same can be said is true for this line. So almost try and sort of imagine that you are bringing together a zip line. That's essentially what's happening here is this value is going to be, as you zip these two lines together, if you imagine that's the center, these two values will basically add up to the same thing, these two values will add up to the same thing, these two values will add up to the same thing. Confused? Keep watching. Although maybe I will, and I'll pay attention to how I do it this time. GDC was helpful in that he showed an example here. So maybe let's go with the larger line. Yep, this one here at the bottom, where essentially you've got the center is clearly 4, 2 and 2 would be 4, 1 and 3 would be 4, 1 and 3 would be 4. And you've got the same thing here, 1 and 2 is equal to 3. So that's the rule set, that's how to play it. And if none of this was intimidating for you, link will be in the description down below as usual to play along. And with that said, I'm going to restart the clock and see how I get on. So I am going to use coloring in an unusual way, in that I am going to go with the same colors, just so that I understand which pairs are associated together. And what I'm probably going to do is, I'll go for, this is red. Sorry, I paused here for a second because I'm really thinking this through now. Let's keep going. I'm going to go with yellow here, orange, some other color, light gray, and black. And I'm now just looking at the red and just thinking purely in Sudoku terms. We know red is not here, and we know red is not there because clearly these two are adding something that's not 0 to get to red. So neither of these are red, neither of these are red. I'm kind of wondering where red is. I'm just going to put a flash in here and just have a think about what all of this means. So the way I'm thinking about it is, at a minimum, what this is telling us... No, I'm going to focus on this one first. At a minimum, what this is telling us is there are at least 2 ways to get to black, potentially 3 ways. Because essentially, yeah, the problem is they can repeat. They don't see each other. But even then, the fact is we've got 3 different digits that sum up to this. And if you use, like, for example, 3, this would be 1 and 2. This could be 2 and 1. But then what is the gray going to be? 3 is not going to work. 4 is not going to work. We've got the same challenge. It can be 1 and 3. It can be 3 and 1. Actually, it could be 2 and 2. So this is 4, 5, or 6, unfortunately. And it includes 4. You can see, I was thinking I'm really looking forward to 6 by 6. This will be easy. It's a 1-star difficulty rated puzzle. But I'm already getting myself into a bit of a twist here. Let me just keep thinking. Actually, here is something. I think we've agreed. Red is clearly not here. That's Sudoku rules. Red is not here because whatever green is adding with, it's not 0. So it couldn't be, for example, red and 0. That doesn't work. So because of that, these are not red. Red is here. Now what it also implies is red is down there. I'm about to lose all these colors because, they're very distracting. So the question is, if this is being added at least 2 different ways. So I'm going to say this is 3, 4, 5, or 6 for now, because this could be 1, 2, 2, 1. Oh yeah, purple is actually sharing it. So 3 is not possible. 4, however, is. Because I can do 1, 3, 3, 1, and 2, 2. That is a possibility. So 3 is not possible. However, because red is joining forces in essence to add up with something to get to black, this, in my opinion, because the minimum is 4, clearly here the minimum is no longer 4, and the maximum is no longer 6. The maximum clearly is now a 5, because you could have a 5, 1 and a 5, 1 adding up to a 6, for example. That would totally work. Unfortunately, so would 4 too, so we're going to have to think about that in a moment. Now, I think 4 and 5 both work. If I can just remove that 1 degree of freedom, I'm fairly sure we're going to be okay at that point. And I think I can. So let's think about where does this go with Sudoku rules. So it's not in here. We know we can't use 0, so it's not there. So this is, one of these at least, is the black digit. And then look at where black can be in box 2. Can't be in here. We're not saying that red plus something adds to black, and then black plus something else adds back to red. That's clearly not possible. That's black. One possibility here is that this is black and red, and then whatever that is to add up to it. So that's kind of possible, but actually no, it isn't. None of these are black. Sudoku, and then the whole can't add with 0, Sudoku, this is black. And black is in here, because again, black can't be added with something to get back to red. So none of these are black. This is black. And we're kind of nearly there in terms of placing all of them. Now, if we think about red, that's red. Still doesn't help me with a degree of freedom, does it? Let me think about this. I may have to sort of change my colors a bit, just to make head or tails of what's going on. I feel so confident it's not a 4. Because in essence, so let's try this for a second. It's 1, 2, and 3. If that was 4, this will be 1, 2, and 3. That will be 4. And these will be 5, 6. Then these will be 1, 2, and 3 again. And actually, let's think about this. So purple wouldn't be here, wouldn't be there. No, I'm making a mistake thinking that these two are the same digit. They don't have to be. But it would make these 1, 2, and 3 again if this was 4. And it means that whatever this digit is, it's not here. And it's not there. It's not here because essentially it's one of 1, 2, and 3. And these two cells basically see all of them. This cell sees here, and we've just proven that 1, 2, 3 is black, which is 5, 6. So that's clearly 5. And I'm going to start tidying this up quite aggressively now. That's a 5. And therefore 5 plus something is a 6. And if we already have the 6 in here, that's the 6, that's the 6. I'm going to just place them all quickly. Clearly, we're not going to have 5 plus something is equal to something other than the 6. That's therefore not the red. This is. And it means that red is also on here. I'm going to, like I said, I'm going to clean this up in a moment. And that moment may actually well be now. Yeah. Right. So that's 5, 5. Let's just clean up all of these so we can make head or tails of what's going on. Right. So to get to 5, it's 1, 4 or 2, 3. Let me make sure I'm actually correctly selecting the right ones. So essentially, that's what we're saying it is. With 6, however, it is 1, 5 or 2, 4. That's not a 5. In fact, if you remember, we said that there is a 5 in here. There's a 5 in there. So one of these 5s will be joined with a 1. The other 5 will be joined with a 1. So we actually have, secretly, a 1, 5 pair in here. Meaning none of these are 1. That's not a 1. None of these are 1. It's now 2, 3, 4. 1, 5. This is 2, 3, 4 again, which would require a 1, 2, 3. Not 1 though. We've got a 1, 5 looking at it. That's 2, 3. That can't be 4. There's definitely a 4 now in here. Look at that. We've got 2, 4 around the 6. That's correct. But it does mean, where was I going with this? So I have no idea where I was going with this. Not a useful one. I'm not going to finish it. We need 1 and 6 in here to finish box 3. Got a 1 telling us the order. That's the 1. That's the 6. So I can actually tidy this up a bit. That's all the 6s done. Excuse me, because there's no 1 in here. That can't be a 4 to add up to 5. There is no 1s in here. Means there are no 4s in here. That's 1, 2, and 3. That's a 1, 2, 3 triplet. That's a 4. That's not a 4. We need a 3 with a 2, 4. Both of these work. To finish this, I really clearly need to think about sums for a second, but let's do, 4 and 1. That's not a 1 either. There's a 1 in here joined with a 2, 3 there. So yeah, time to do some sums. Can I deduce anything about this? The fact that this is not 1 anymore, that's not 4. And therefore this is the only 4. This is the 2. That's not 2. 3, 4 would go with 1, 2 here. 2, 3, 4 is still 1, 2, 3. This is 3 or 4 to finish the row. That 4 tells us the order. That's the 3. That's the 4. That 4 tells us this is a 1. That's not a 1 anymore. That's not a 4 anymore. 2, 3 tells us this is a 4. 4s are done. There's a 5 in here, which finally gives us an order. Because essentially we need a 5 in box 6. This 5 tells us it's not in here, it's there. That's no longer a 5, that's a 1. And therefore that's a 5, that's a 5, that's now a 1. This 5 tells us where the last 5 goes. And we can just finish up from now. 1, 2, 3, 2. This 3 adds up with a 2. This 2 adds up with a 3, 2, 3. That has to be a 2. Sudoku, 3. And that's the solution to today's puzzle. Wow. Well, I think if anything, it just, I mean, yes, it's under 15 minutes, but it just illustrates how difficult these puzzles can be. So yeah, imagine a 9 by 9 puzzle and expect that soon coming to you sometime this weekend. Thank you very much for featuring this and creating this, GDC. I love the new rule set. You know, it's another thing to wrap our minds around and just keep us a bit more agile. And a 6x6 is a lovely introduction to this rule set. But despite that, the fact that you had this degree of freedom for a long time in the puzzle, it just forced you to think really hard about how do I actually unravel it all. Hope you enjoyed today's video and see you back for the next one. Bye for now.